All right, good morning. This is the academic lesson for Thursday the 9th. This is our warm-up. We're finding which one is the best five. We already talked about it in my class. Since we're looking at different different amounts of shirts, the best way to compare them is to find the cost of one shirt in each situation. Okay, so go ahead and solve that. We can use unit rates from Tuesday, I believe. Monday, maybe Monday, when we talk about unit rates and unit costs. So pause and play when you're ready. All right, so let's find out. So again, we are finding basically the unit price. And another way to say that is the price per shirt. The price per shirt. So when I set up my proportion, what unit am I going to put up top? Price per shirt. It tells me the order. I'm going to put the price or the cost up top, and on the bottom I'm going to put the shirts, the number of shirts. Okay, I'm just going to put okay, I'm going to do the first one, $25.50 for 6 shirts. I want to find the cost of one, so we probably, even without setting up a proportion, know that we need to do what? Divide by 6. Very good. Okay, let's do a little bit of a review because this does have decimals in it, so maybe it's been a second since we divided with decimals. 25.56 divided by 6. Okay, remember with division, we want to stay very organized. Does 6 go into 2? No. Does it go into 25? Yes. How many times? 4 to give me 4. I'm left with 4. What do I do now? Before I do that, I'm going to move out my decimals just so I don't forget. A few of us yesterday on our test forgot our decimals. They just disappeared. You forgot that they existed. Let's not forget that they existed. Okay, now I can bring down that 5. 6 goes into 15. 2 times to give me 12. Very good. 3. Good. 6. Am I left with anything? No. Good. Okay, so that's $4.26 for one shirt. Okay, $4.26. Yeah, that's pretty good. $4.26. Okay, are we good with that? Yes, ma'am.
It wasn't $25.56.
Okay, so that's just this little couldn't read her own handwriting. Sorry. Thank you for letting us know. Okay, so that should be 30. So 6 goes in 35 times. I'll just fix that for you. Please let's silence our phone if we can. We can rewrite that. 425. Okay, are we good with that?
Yeah.
All right. I'm just gonna erase this and just
Everybody's fine.
Okay, I'm just gonna reuse that proportion since it's gonna be a lot of the same stuff. Okay. Next one. I'm gonna put what up here?
18.
For this next one, class, what am I going to put up here? 18 over 4. Very good. I'm still solving for the unit price, so I need to, in this case, divide by 4. More than just one, please. Whatever I do to the bottom, awesome job. We're going to do 18 divided by 4. Class, does 4 go into 1? No. Does it go into 8?
Yeah.
How many times? 2 times to give me.
It goes in 4 times.
Okay, sorry, I thought y'all said 2. How many times?
4
times to give me 16. It does fit in 2, but it also fits in 4. So we want to go bang for our class. Class, it goes in. Or I'm left with 2.
Add a decimal.
Decimal, add a 0, bring it down. Goes in 5 times. Am I left with anything? No. 4.5. That's not money.
$4.50.
Very good. Awesome. 4, 6. Okay, so right now, just looking at those two, which one's the better buy? A right now is the better buy. Okay, I'm gonna go ahead and eliminate B because I already know I got it B. Okay, last one. Last one. That's 21. Okay, give me a second. Y'all too fast for me. Okay, so y'all said how many? 21 over 5. So in this case, I need to divide by 5. Okay, so 21 divided by 5 It doesn't go into 2. Again, I'm taking it step by step. I don't want to rush myself. It goes in
4 times.
very good. 4 times. You are correct. I'm left with 1.
At 0. At 0.
She goes in 2 times.
At 0.
4.2. 4.20. Very good. $4.20. So looking at those two, which one is the better buy? C. I saw that I was trying to give people some good stuff. Are there any questions on that? Woo! Awesome. Any questions? All right. Awesome job. So that's just more on unit rates and stuff like that. Continue to get comfortable. We'll review this when we come back. This will be on our finals. Boy, thank you. This will be on our finals for next week, but we'll also review it when we come back because we've still got a little bit to touch on. So when we come back from the holiday break, we'll do some more of this. Okay. So what's going to happen is you should have picked up 2 papers. We're just going to do a couple problems from each one because they're very tied together, and honestly, y'all are pretty good at it. Okay, y'all, the proportions were rock solid on those now. Okay, and so we're not too bad. Okay, we're getting better. I mean, we're not perfect, but we've made improvements over the past few weeks. So let's continue to grow in this strength. Okay, so please put this one on top. You got 2 worksheets. Put this one on top. Let's do a couple together. The first problem says a pronghorn antelope can travel 105 miles in 3 hours. If it continues traveling at the same speed, how far could a pronghorn travel in 11 hours? Now, what do you think we're going to be using? A proportion. What 2 units did it talk about in this problem? Hours and miles. I usually do miles per hour, so that's what I'm going to do. Technically, I could do it either way, but I just like it like that. Okay, so class on this side, I'm going to put
5
over 3, and then that 11 is going to go
on the bottom.
Okay, I can't tell you how many people I've now seen put their units and be more successful on their tests and on their problems, and the people who are still refusing are still getting things switched up. Please put those labels. All right, so class, this 3, can I go side to side? This 3 going to 11 in a pretty way? No. It's probably a decimal, but I'm going to avoid those as much as possible. So let's look up and down. Okay, would I work up or would I work down in this case? I would work my way up because I have to work towards the end. So let's figure out. Okay, I'm already letting you know that it is a multiple of 3. Do y'all remember how to tell if a number was a multiple of 3? How could we tell that 105 is a multiple of 3? We talked about this a while ago. Lana, what do you remember? Not quite. Very good. I add up the digits. 1 plus 0 plus 5. What is that going to equal? 6. Is 6 divisible by 3? Yeah, so that means 105 is divisible by 3. Okay, so I don't know my scale factor, but I know it's going to be a whole number, so let's figure that out. To figure out that scale factor, do y'all remember what I need to do? Divide. I'm going to do 105 divided by 3. Let's rock and roll. I'm doing it with you, so it's not too bad. This 3 goes into 1, but it goes into 10 3 times to give me minus 10 is 1. Bring down to 5. Gives me 5, 15, 0. So my scale factor is it a decimal? No, it's just times 35. Go ahead and take a second, do 11 times 35. Pause and play when you're ready. All right, what did y'all get?
385. 385.
Let's check.
Okay.
5, 3, 0, 5, 3.
Yeah.
Okay, thank you so much for talking out during my lesson. 5, 8, 3. Math errors happen. Oh, it's okay to have math errors. This is like we'll always get partial. So that would be 385 what?
Miles.
Oh, 385 miles per hour. Oh, talking about hours. No, it's not miles per hour. What is it talking about?
No.
Thank you, Rory. Sorry about that. 300 miles in 11 hours. Very good. Next one, number 2, out of 32 students in a class, 5 says that they ride their bikes to school. Based on these results, how many of the 800 students in the school ride their bikes? So what 2 things are we talking about? We're talking about students and bike riders. When we're talking about that, which one do you think we want to put on top? Bikes, because it's very good, because that the students is the total number, it's that whole number. So I'm going to put bikes over students. 5 over 32, and it's saying based on these results, how many of the 800 students in the school ride their bikes to school? So that 800 students are where? The bottom, so that is my total. What are we thinking? Up and down or side to side? Yeah, I know for a fact up and down is going to be not pretty, so let's try side to side. So how can I find that scale factor? I need to divide to figure out what to multiply by. So 800 divided by 32. Okay, give me a second to pause. Okay, it doesn't go into 8, but it does go into 80. 2 times to give me 64. I'm left with 16. 0. So the way that I sometimes use estimation is I want to end in a 0, and I know 2 times 5 gives me a 0. I'm just going to try that. That's too much. So 32 times 5. I did this before. Okay. Take a look. It is 25. So is 25 my answer? No, 25 is my times number. What's that time number called? Kennedy, say it one more time. My scale factor. Thank you. Okay, so I need to do 5 times 25. If I have 5 quarters, 4 makes 100, plus another one is 125. All right, I'm going to let y'all do that in a second. I want to go ahead and do the second part of the lesson if that's all right with y'all. Is that cool? Are y'all ready to go? Let's do mine. Y'all do number 3, and then we'll move on from there. All right, let's look. What did y'all put on top in your proportion?
Money.
Monies and counts. Doesn't matter if you switched it.
No.
Okay, let's do it both ways. If we're so picky. You don't have to do it both ways, but see which way that you did it. Over here, what would I put over what?
6 over 3.
6 over 3, and I put the 10 on the bottom. Very good. I would put that 10 on the bottom. So up and down or side to side over here. Up and down. How do I go from 3 to 6? Minus 2. And that would give me, pause. Thank you. So awesome. Okay, over here, what would I put over what?
3 over 6.
3 over 6. Where would I put the 10? On the top. Very good. Look at that X. Okay, Hudson, how do you do it? Side to side or up and down? What do you do side to side? Or up and down, sorry. What do you do? I have to work towards my X, so switch that. I need to do 3 times 2. Very good. 10 times 2 classes. 20. No matter which way you work it. Yes. I do it in my head. Cool. But I got the wrong. See? And that's why y'all just back me up.
I got 21. I did it.
Okay. So, do we understand it? All right, moving on. Just going to go through the other one, the other worksheet. It's very similar. Very similar. We're still going to be doing rates. We're still going to be doing proportions, but we're going to do something called a ratio table. All it is a ratio, and they put a box around it, okay? Like this is proportional to this, and they just put it in a pretty box.
It's even harder when it's in a.
All right, so again, we're going to talk, the last little thing is ratio tables, which is just ratios in a pretty box, okay? So they have like a recipe, you know, like when you make a recipe, they might call for 2 cups of flour with 3 cups of water, okay? But if you double the batch, that would be how many cups of flour? 4 and 6. If I tripled the recipe, that would be 6 and 9. Are y'all good with that?
Yeah.
Okay, but it's going to be the same portion. The reason why that works is because it all simplifies down to that same thing. Okay, so equivalent rates express the same relationship. Okay, they all express the same thing. Okay, the reason why they're equivalent is because they all simplify down to the same thing. In this case, they all simplify down to 2/3. 2/3.
Oh.
All right, and then ratio tables. Again, just help us organize that. It's basically a proportion of the box. Okay, it just helps us see the flow of things. I'm going to do a few with you, and then you'll hear a few on your own. Okay, first problem, just some real world examples. To make a clean solution, you mix 1 cup of bleach with 16 cups of water to dilute it. Okay. How much bleach should you mix to get 80 cups of water? Notice that they beautifully put their label, so I know where the 16, the 80, and the 1 go. Do y'all want to go up and down or side to side?
Up and down.
Side to side, what would it be? Times 5. Do I have to go up and down, or do I have to go side to side? No, there's also the up and down relationship. It's just whatever works for you. Class 1 times 5 is 5. Okay? That's the same thing we've been doing. I'm going to write my answer nice and pretty. 5. You have my labels to help me out. Cups of bleach. Okay? Good? Okay, over here on number 2, you'll notice that there's an empty box in the middle where you can or you don't have to use it. If you don't use it, you can go straight from 12 to 2, but we'll talk about it in a second. I'm going to let y'all solve it real quick. 1. All right, Joey Chestnut won a hot dog eating contest by eating 66 hot dogs in 12 minutes. Yes, this is a real person, and yes, he actually he's a competitive eater. If he ate at a constant rate, how many hot dogs would he eat every 2 minutes? So again, I mentioned we can go straight from 12 to 2 by doing what class? Divide by 2, not 6, but by 6. In this case, pause. Divide by 6. 66 divided by 6 is 11. Very good. But, okay, let's go with what Rory said. I like what she said because it wasn't wrong. If I had divided by 3, are both of these numbers divisible by 3? Yes. Absolutely. What's 66 divided by 3? 33. And then 12 divided by 3 is? Not 6. 12 divided by 3 is? 4. Very good. Okay. It's okay. We're good. Okay. This is in case, you know how sometimes y'all don't remember how to get straight from one number to another? What is this? What am I basically doing right here? I'm simplifying. Very good. And then I can simplify again. Oh, no, it's not 33. Sorry, guys. It's not 33. It's not 11 in the middle. 66 divided by 3 is 22. 22. 22 and 4. Again, I'm not at 2 minutes yet. How can I get from 4 to 2? Divide by 2. 22 divided by 2 is 11. Okay, so it's a couple of ways. It's proportions, and we've talked about that. Okay, do I have to use that middle box? No. Okay, so my answer, no matter what, is 11 hot dogs in 2 minutes. All right, so what are we doing here? We are multiplying or dividing the related quantities by the same number. When we do that, like this, times 5 and times 5, what's that number called again? It's called my scale factor. Everyone say, what is it called?
Scale factor.
Scale factor. Seems to have forgotten it. Okay, that is my scale factor. Scale factor. Okay, again, scale, you can scale up, you can scale down. Factor means what operation? Factor means, class, it means multiplication. Factoring means what? Multiplication. Thank you. Whenever we do proportions, whenever we use scale factors, what operations are we always using? We're always using multiplication or division. Okay. Whenever we scale in a proportion, we're always doing what two operations? Multiplication and division. We're always doing multiplication or division. What operations are we never doing?
Addition and subtraction.
We're never adding or subtracting. Add or subtract. Okay, and maybe we haven't talked about this, so let's talk about it for a quick second on why we do. Okay, on yesterday's test, there was a question on the back where it had, I don't remember the problem exactly, but it had something like, what was it? It was like 30, and then we were trying to figure out 30 and 63, and it was like 50 or something like that. And quite a few of y'all added 20 and then added 20 and got a wrong answer. And that's not how it works, okay? When we do proportions, okay, the whole thing is that it's a fraction equal to another fraction, right? If I had, let's say 4/8, and I doubled it, what would that be?
8/16.
8/16. Does that still equal like half of it?
Yeah.
Okay. What would happen though if I added or subtracted? Let's say I had 1/4. What's 1/4 as a decimal?
0.25.
0.25. I agree. What if I added 1 and added 1? That would become 2/5. What's 2/5? Do y'all remember? It's 0.40. 0.4. Are those two sides equal?
No.
No. Okay, so I can't add or subtract in a proportion because it doesn't stay equal. I always have to do
Multiplication or division.
multiplication or division. Okay, so some of y'all who added or subtracted yesterday, that's why it didn't work out. Okay, I'm going to do one more with y'all and then I'll set you free. Skim milk contains about 80 calories for every 8 ounces. How many calories do 10 ounces of skim milk contain? So in this one, can I go straight from 8 to 10?
No.
No. So what is a possible thing to do with 8 to 80?
9.
I could divide, what can I divide them both by?
10.
Divide them, I can't do both of them by 8. Oh, sorry, I can't do them both by 10 because this doesn't end in 0, but I could divide them both by 8. Let's do that. Divide them both by 8. Oh, Lori, maybe I know what you're talking about. Okay. 8 divided by 8 is?
110.
And then 80 divided by 8 is 10. Very good. Yes, 110. Okay, can I build that up now?
Yes.
Yes. How would I do that?
Times 10.
Times 10, and times 10 gives me 100. It's a journey to get there. It's simplifying and then building it back up. So what that is, that's called scaling down, simplifying. Scaling down is the same thing as simplifying, and then scaling up. Okay? But Rory, I think maybe that was doing, she was working her way down. Is that what you were doing?
Yeah.
And that's times 10. That's what that's 10. Oh, well, in this case, you would multiply. Okay. That would give you the same answer. So in this, my answer is 100 calories per 10 ounces. Okay, do that last one. Ready, set, go. All right, for this one, what did y'all see? Can I have a volunteer? What did y'all see? Rory, what did you do?
First, I got 50 divided by 2 because I get 7 on the top and then 4 on the bottom.
Okay.
And then still working out the,
Okay, can someone take over from there? Yes, ma'am.
you multiply by 7.
Good. And then times 7, that would give you 28. Did anyone else get 28?
Nope.
Yeah, just got it. Just got it. Awesome. So that would be 28 lawns. Okay. So just summarizing, we've already talked about this quite a bit. Whenever like we can't get straight from one number to another, we scaled it down. Another way of saying that we simplify. Okay. Whenever we simplify, we find a common factor or common, yeah, whatever you want to call it, common factor between those two things, whatever you can divide them both by. That's why we teach you those divisibility tricks of like 2 for even numbers. If it ends in a 5 or a 0, it's divisible by 5. If it ends in a 0, it's divisible by 10. Great. Okay, it's all those tips and tricks. Okay, the last little bit. In scaling, we multiply, the number we multiply is called, one more time. In scaling, the number we multiply by is called the scale factor. Awesome, getting better at that day by day. And we said scale factor, technically factor means to what operation? Multiply. Okay, so in this problem right here, I'm going to challenge y'all a little bit, and I'm about to trick y'all, and you're all going to be like, Miss Lytle, what you said. Okay, our scale factors in this problem, the numbers we multiply by. What did we multiply by?
10.
We multiplied by 10, but we divided by 8. Ooh, so I'm going to make it spicy here real quick, but stay with me. Okay, if I divide by 8, that's the same as multiplying by a number, but let's figure out what that number is. What do you think?
2.
No. No.
5.
No. 4. No. Okay, I'm going to let y'all know. So pause. Let me add to this. when I divided by 8, 80 to 10, did that make my number bigger or smaller? Smaller. So am I going to be multiplying by a whole number to get it to be smaller?
No.
Fraction.
No, not negative. My numbers aren't negative.
Like,
It's going to be like a decimal or a fraction.
I said this.
Okay, great. And I just say you were wrong. You're right. Okay? It's going to be a decimal or fraction. But what decimal or fraction? So let's take it back to the second 6 weeks time. Way back to the okay? So how can I turn 8 into a fraction?
You put it over 1.
Put it over 1. Hey, whenever we divided by fractions, that's the same thing as multiplying by
The reciprocal.
the reciprocal. So class, real quick, boys over here. Whenever I divide by fraction, it's the same as multiplying by the class. Whenever I reciprocal. Whenever I divide by a fraction, it's the same as multiplying by it.
Reciprocal.
What's reciprocal in this case? 1
1
over 8. 1 over 8. 1 over 8. Thank you for those of y'all acting like mature 6th grade students. Again, we're recording this, so I would hate to email any parents of students who are disrespecting our classroom environment. That'd be unfortunate. Okay? So my scale factors in here are times 10, and instead of divide by 8, I could also write times what?
0.12.
Oh, what fraction? Times
1/8.
1/8. Okay, my scale factor is 1/8. This line was never going to make you write it like that, but it's just understanding that the scale factor was a fraction because my number got smaller. Okay, so what you're going to work on for the rest of class are just any of the problems you didn't get to very quickly. We're not going to get to this close line. So I'm just going to say for tonight, work on finishing any problems that we did not get to on main